Welcome back to Balancing and Predicting Redox Reactions. We're at the predicting stage now, and one of the first things you want to do is learn to identify this as a redox reaction. And this word concentrated helps us do that. Concentrated, dilute, acidified, alkaline are all words that we want to be paying close attention to. In this case, we have nitric acid, so I have HNO3. Ic came from 8, and nitrate is NO3, plus solid copper yields. Now, at this point, you have to have memorized what the product. You have to memorize that concentrated nitric acid will form NO2, and that the copper will form 2+. Remember the phrase, as Snoopy fell, huge cups. The CU in cups tells us that copper goes to its upper oxidation state. So, as Snoopy fell, huge cups cracked. So now what we want to do is first start with our balancing of our electrons. So to do that, we need oxidation numbers. And I'm at the point I can do these in my head, but you may well have to do these on paper and do a little bit of algebra to make sure that your charges balance. Now, copper goes from 0 to copper plus 2. That is less negative, which means that copper lost 2 electrons. Our solid copper was oxidized, and hence it's our reducing agent. The nitrogen went from +5 to +4. That is more negative, so we have to give it those negatives, and in this case it's 1. So it gained 1 electron. We have to have a balanced number of electrons, the lowest whole number ratio between the 2 electrons that copper lost and the 1 gained is to multiply this one by 2. So I'll put a 2 in front of those 2, and I like to go ahead and put in these ones explicitly so that I'm not tempted to change them later on. Now, it did say that we have an acidic solution, so it would be common to actually acidify that. It doesn't say specifically, but the nitric acid tells us it must be acidified solution. And so we need to balance our oxygens with water. I have 6 oxygens on my reactant side, and I have 4 oxygens on my product side, and so I'm deficient 2 oxygens. So in an acidic solution, you add a water for every deficient oxygen. So now I want to look back and balance my hydrogens. I have 4 hydrogens on this side, H pluses, and hydrogens. This side I have 2 H pluses. So I need to add extra H pluses on this opposite side. Now, AP does require you to have the net ionic reaction. And since our nitric acid is a strong acid, I need to dissociate it 100% to get my final reaction. So I would dissociate these 2 H pluses, and I'm just going to merge them with these 2. So I would have 4 H pluses plus my 2 nitrates from the dissociation of the acid plus copper yields 2 NO2 plus copper 2 plus 2 waters. So that would be my balanced net ionic for this reaction. Okay, let's go on to the next one. I'm going to do 4 AP questions. It'll probably be in 2 clips so that they won't be too long. And the next one is a solution involving tin 2 ions and acidified. Again, that word acidified is a good hint that we're talking about redox. The other hint you may be paying close attention to is dichromate. It's a very common oxidizing agent, and so that's another hint. So we have tin plus 2 ions. We don't care about the counter ion because we're dealing with net ionics anyway. Now, potassium chromate, that is a solution of potassium ions will never participate in a redox reaction in an aqueous solution. So rather than continue to write them down, I'm going to eliminate those at the outset. So I know potassium ion because it's a solution of, and potassium cannot be reduced in the presence of water. Now, again, we have to do a little bit of memorizing here. In an acidified solution, dichromate will yield chromium 3+. Now, what's not obvious yet is that a reduction, or is that an oxidation? So let's assign numbers. I have +2. This is -2, which leaves chromate as +6. So in this case, this became more negative. And since there are at least 2 chromium ions, or chromiums here, that have to be reduced, I go ahead and count that at this point. So I like to put in that I'm going to have to deal with a minimum of 6 electrons. Now, since the chromium was reduced, that means the tin had to be oxidized. And that's how I know this goes to tin +4. You should know the common oxidation states of tin, or you should be able to figure them out on the periodic table as well. And so tin was oxidized, it became less negative, and lost 2 electrons. And now what I want to do is balance my electrons. The lowest whole number ratio between 6 and 2 is 6. I'm going to multiply that by 1 and this by 3. So I'll have 3 tins on both sides. I'm going to have a 1 here, but I do have to put a 2 here on the chromium ion. So be really careful when you have polyatomics that have more than 1 in the chemical formula. At this point, I have to balance my oxygens. I have 7 oxygens on my reactant side. I have 0 oxygens on my product side. And again, since we are in an acidic solution, I balance deficient oxygens with water. And that now gives me 14 H's to worry about. Since there are 0 H's on this side, I have to balance those. And if there's an acid around, there's plenty of H+ to go around. So that would yield my final reaction. It's already the net ionic reaction. And so that's all I need to do. It's complete.